right, Mary C. Williams, fourth graders, let's take a quick recap from your first 3 days of instruction. So on your first day, you learned some fraction vocabulary and you made your vocabulary pages and turned them into your teacher. This was your second vocabulary page that you knew the parts of a fraction. And so you knew what area models and linear models were. Day 2 of your instruction, you used your models to create fractions. So you made area models and linear models of fractions. And then on day 3 of your instruction, you took that knowledge for creating area and linear models and you learned how to line up your models and then compare fractions using greater than, less than, or equal to. Today, we are going to continue that understanding. All right, friends, so after that quick recap, let's get down to business. So your independent work today will be on page 105. I'm going to go over this first part, and then your job will be to answer questions 3, 4, 5, and 6. And I do not want you just to write less than, greater than, or equals to in the circle. I also want you to prove it. So please use either an area or linear model also. So you do not have to make both. You do not have to make a linear and an area. You need to choose which one you would like to do. Try to mix it up a little bit. Try to make a couple area and a couple linear. All right, so you know what your task is. Let's go over the top part. All right, friends, so our objective is going to be to compare fractions, and initially in the top part they are comparing fractions using an area model. Now this area model looks different than a regular circle or a rectangular area model that we have been using. Theo filled a beaker 2/4 full with water. Angelica filled a beaker 3/8 full with water. Whose beaker has more water? So our job is to compare 2/4 and 3/8. Step 1, divide one beaker into 4 equal parts. Well, that would be Theo's beaker, because Theo had one that was 2/4. So we're going to divide Theo's into fourths. 1, 2, 3, 4 equal parts. Divide another beaker into 8 equal parts. So Angelica filled hers 3/8 the way full. So we're going to cut her beaker into 8ths. 1, 2, 3, 4, 5, 6, 7, 8 equal pieces equals. Okay, so that means Theo has 2 fourths. And Angelica has 3 eighths. So 2/4, 3/8. All right, so we've divided our beakers up. We need to shade 2/4 for Theo, which they have done in the darker coloring here. So 1/4, 2/4. And then shade 3/8 of the second beaker. 1, 2, 3 of the 8th. So shading 1, 2, 3 parts. Compare the shaded parts of each beaker. Half of Theo's beaker is shaded. Less than half of Angelica's beaker is shaded. So they're using halves as a benchmark fraction, which you are going to be learning more about. So this is the halfway mark. So Theo has 2/4, which equals the same thing as 1/2 shaded. But Angelica has less than half. She hasn't even made it to the halfway point yet. She only has 3/8. She would need 4/8 to be at the halfway mark. So 2/4 is greater than 3/8. Now, it is very important for you. I'm going to put a little fact box on my paper. or up above it. Put a little fact box up here. It is very important when comparing fractions to make sure that you are comparing same size wholes. For example, same size rectangles, which you see down here, the number line and the rectangles begin and end at the same spot. The same thing is true for these two beakers here. These beakers are the same size. So when comparing fractions, it is important that you remember you're not going to compare 1/4 of a personal size pizza to the same 1/4 of a large size pizza. You want to make sure that what you're comparing are the same size wholes. This is one whole beaker and it is the exact same size as this whole beaker. All right? Okay, so that's my little text feature fact box that talks like Miss Todd and Miss Brisson are doing text features this week. All right, my friends, so now let's compare 1/2 and 1/4. 1/2 and 1/4. 1/2, if I take 1/2, the denominator tells me that I need 2 equal parts. So 1/2, 1 part, 2 part. The 1, or the numerator, tells me I'm going to shade just one of them. So I'm talking about just one, which has already been done for me. So I'm going to shade the 1/2, and then I'm going to make my second rectangle and cut it into fourths. 1, 2, 3, 4. And I'm only going to shade, again, 1 part. So 1/2 compared to 1/4, which is greater? Which is greater? Well, I can obviously tell from my area models that 1/2 is greater than 1/4. I also know that if this is my linear model and this is 1/2 here, I can easily use this line to come up here and put 1/4 on the number line, and I can tell that 1/4 is closer to 0 than 1/2. So I can tell again, using a linear model, that 1/4 is less than 1/2. It is less than 1/2. All right, friends, moving on to 2/3 and 3/6. Here is 0, here is 1/2. This is a benchmark fraction. We're using the benchmark fraction 1/2. To compare 2/3 and 3/6. Well, let's look. 2/3. This denominator tells me that I'm going to cut my rectangle into 3 equal parts. 1 part, 2 part, 3 parts. I am talking about 2 of them, so I'm going to shade 2 of the 3 parts. I can also use this line here to help me place 2/3 on the number line. Let's look here. 3/6. I'm going to split my rectangle into 6. This one was split into thirds. I'm going to split it into 6. 1, 2, 3, 4, 5, 6. I'm going to shade 3 of the 6. 1, 2, 3. If I use this line where 3/6 ends to place 3/6 on my number line, I know that 3/6 is the same thing as 1/2, which is true because 3 is half of 6. So in this case, which is greater? Is 2/3 or 3/6 greater? Well, 2/3 is closer to 1 than 3/6 is, and 3/6 is closer to 0 than 2/3. So that means that 2/3 is greater than 3/6. All right, my friends, while you are doing yours, I want you to use either an area or a linear model to compare these so that you can justify your answer and prove it. All right, one last little reminder. I just want to make sure that I stress this to you. Remember that your rectangles need to begin and end at the same spot, or your number lines need to begin and end at the same spot. You have to be using the same size holes when comparing fractions. All right, my friends, I hope that this was helpful. Please turn this into us through Class Dojo or through Google Classroom, whichever you prefer.